All right, hello, good morning, everyone. Today we're solving LeetCode 78 subsets. Given an integer array of nums of unique elements, return all possible subsets, the power set. The solution must not contain duplicate subsets. Return the solution in any order. All right, so there's a couple examples here, but I have this quick and easy example that should be easy to follow. So first, we need to know what is a subset. A subset is just all the possible combinations of either picking or not picking a number for every number. All right. And what I mean by that is, in this case, the first subset means we chose not to pick the 3 and not to pick the 5. This second subset means we chose to pick 3 and not pick the 5. We chose to pick the 5 and not pick the 3. And the last subset, we chose to pick the 3 and pick the 5. And when it says it must not contain duplicate subsets, that means that 3 and 5 is equal to 5 and 3. So we don't want to have both of these because these are considered equal in subsets. If this was permutations, these would be two different permutations, but it's not. So we want to make sure to omit at least one of them. All right. Now back to what I was talking about with we're either choosing to pick a number or not pick a number for every number. Let's say we start off with an empty array, because as you see, each subset is denoted as an array. And let's just say we're looking at the numbers 3, 5. First, let's say, hey, we can either take the 3 or not take the 3. Let's say, what happens if we skip the 3? If we skip the 3, our array remains empty. And on the other hand, if we take the 3, we have an array with 3. Next, let me zoom out so I could make sure you guys could all see this. Next, we say, well, we decided on what we're going to do with the 3. So this is the branch where we decided about the 3. Now let's decide what happens at 5, right? So this is the branch where we decide what happens at 5. We can either not take the 5, so in this case it is an empty array, or we can take the 5. 5 is the last element in our nums array, so there's no more branches. Now we're going to go on to the right side. Same thing. If we decide to take the 5, that means we'd have 3 and 5. And if we decide to omit the 5, we would just have 3. And as you can see, this is all of the subsets that can be made with the numbers 3 and 5. And to omit duplicates, what we're going to do is tell our function when to start. In this case, once we've decided what we're going to do with the 3, the next call shouldn't have to decide what we're going to do with the 3. It should immediately start at what we're going to do at the 5. And once we get into the code, I'll explain that. So before we do that, I want to get into what is the time complexity of a solution like this. It would be big O of 2 to the n. And you might say, all right, what does that mean though? N just denotes how the length of our input array, in this case, 2. So as you can see, that would be the depth of our decision tree. So this would be 0, 1, and 2. And 2 represents the branching factor. At every node, we have the decision to either take the element or to omit the element. So that is a decision, 2 decisions. So that's why there's a branching factor of 2, right? So hopefully that makes sense on why it's 2 to the end. And if I quickly reiterate, n stands for the number of elements. So that's going to be the depth of the tree. And 2 stands for the number of decisions, i.e. the branching factor. That's why every node has 2 branches except for the leaf nodes, because there is no more numbers to take. All right, so let's get into how we'd solve a problem like this. The first thing maybe that's a bit too much zoomed in. The first thing I love to do is make the res array. Because as you can see, all of the subsets are appended onto this array. It's a 2D array, so we want to have the container that's going to encompass all of them. Next, what we're going to do is create a function called DFS. So define function DFS, and it's going to take in a sub, and I'm just going to call it sub short for subset. And we need a start to tell the DFS function what element we're on. All right, and that's the bit of a tricky part, so I'm going to make sure to go back to the diagram when we get there. First, what we want to do is append our subset to res. So res.append sub, and make sure that it's a copy. I've made this mistake many times when I was first learning backtracking. Since arrays are stored by reference, we need to append a copy to res, because if we just appended the reference of this array into res, once we modify it, it would modify inside of res. So just make sure you always do a copy. All right. Next, what we want to do is have a for loop that's going to iterate through nums and get all the subsets. So this is where the real magic happens. So we say for I in range length of nums. We want to say sub.append. So we're appending on our first element, sub.append nums of I. So if I is 0, so if I is 0, then we're going to append the element with the index 0. So in this case, the 3, right? And we want to include our start, because this will tell us where our element has to start at. Because if we did not have start, we would append on the 3, and when we call DFS again, how would it know? It would try to add 3 again, but we can't use 3 twice because there is not 2 3s. So it just makes sure that once we're at the 3, we're now deciding on what to do at the 5. All right. So that's why we have the start here, to make sure we don't have any duplicates. All right, so we've appended our number to our subset. Now we have to explore that path. So we say DFS with the subset that we just appended, and then we need I plus 1 for start. So if I was 0 and we looked at the number 3 and we just appended it, now we want this DFS call to determine what we do with the 5, right? All right, so once this function call ends, that means we've explored all the possibilities starting at number 3, right? But 3 is still inside of our subset array, so we need to pop it off. So sub.pop. So this is essentially undoing our work so we can start from a fresh slate and start off with the 5. So we pop that off, and that's essentially the entire algorithm. So now all we have to do is call DFS with an empty array and a 0 for the start and return res. All right, and let's see if this works. All right, there, and it works, and it's pretty efficient. It beats 100% of runtime complexity. So I hope you enjoyed the video, and if you have any questions, please comment them down below and drop a like. It really helps the videos.